Hello, in this video, we will talk about confidence intervals. This is actually an introduction to this topic since it's the first video in this chapter. So we will start with some definitions and some ideas, the process of constructing confidence intervals. Let's get started. In previous chapters, we have generally assumed that we knew the parameters of distribution. So you do recall that in previous chapters, mu was given, sigma was given. We knew the parameters, right? However, that was an assumption because the main idea in statistics is to try to get to the population values to these parameters, knowing the information from samples. So in practice, actually the population mean or the population standard deviation and the population proportion are, of course, unknown. So this is what we will try to do in this chapter. We will try to develop methods of estimating these parameters. And I gave you this example because we worked with the mean and the standard deviation, but we will also add the population proportion. Here is the whole idea. In statistics, we work with samples for different reasons, of course, and here is a statistic, which is the mean of the sample. We know the notations by now. This is the standard deviation of the sample, and we will look at this one. This is the proportion of the sample p hat. Now, the main goal here is to somehow arrive closer to the parameters. Here is the mean corresponding to the mean. Here is the sigma corresponding to the standard deviation. And here is p, the population proportion. How can we get from the statistics to the parameters? This is what we will start today with confidence intervals, and then we will continue with inferential statistics, doing hypothesis testing, and regression later. But today we will take care of methods of estimating these parameters. So I will not be able to say what these are, okay? But at least I'll be able to create what we call a confidence interval to estimate these parameters. And how is it possible? Well, we talked a lot about probability. We talked about central limit theorem. So we will apply all of this here and we'll be able to get somewhere closer to these parameters. So let's get started with the definitions. A point estimate. A point estimate is a specific numerical value of a parameter. In other words, is the sample statistic, which is the starting point to estimate the parameter. And in order to understand this, we are trying to see, okay, what will be the starting point if I want to estimate the mean? Well, if I want to estimate the mean, where should I start? One single value or a sample statistic? Well, it makes sense that I will be using X bar. So this is actually the point estimate. Point estimate for the mean is X bar, for sigma will be S, and for P will be P hat. These single values starting points are called point estimates. So as we've seen, the best point estimate of the population mean is the sample mean, which is denoted X bar. The best point estimate of the population proportion P is the sample proportion, which is P hat. And the best point estimate for the population standard deviation sigma is sample standard deviation S. So that's where the process starts, at the point estimate. Let's see what we do next. Next, we will try to estimate the population parameter. What do we mean by that? We will try to construct intervals around the parameter. So let's recall what an interval is. An interval means between two numbers. For example, X is between 3 and 7. This is an interval. This is called the inequality notation or the inequality form. However, there is another form to write an interval, which is called the interval notation. So the same interval can be written this way. For example, if I have this 10 plus or minus 3, what do I mean by that? This is what I mean. Add 3 and subtract 3. If I add 3, I have 13. If I subtract 3, I have 7. So the lower bound will be 7 and the upper bound will be 13. So this means the interval between 7 and 13. This is exactly what we will try to do in this unit. We will take the point estimate and we will add a constant to it to construct a confidence interval. You see, the new word here is confidence. What do we mean by that? It's not just a simple interval. This interval that we are trying to construct, it comes with something new, and this is called the confidence level. Let's talk about that. The confidence level, for short CL, of an interval estimate of a parameter is the approximate probability that the interval estimate will contain the parameter being used. So the confidence level is actually a probability that the interval that we will construct actually contains the parameter being used. And that's an interesting thought. We think, well, if we construct an interval and we say that, for example, and I'll just make up this example right here, and if I construct an interval and I say, well, the mean is between 7 and 13, based on the previous example, right? I will be thinking, well, the mean is between these two numbers. Well, nothing is perfect. And actually, the confidence level tells us, well, there is a chance that even if we've done all of this correct, the mean might not be in this interval. This interval is associated with a probability. Most likely it will be, but there is a chance that it will be outside the interval. All of this will make more sense when we will actually do examples. And I will show you a visual then, and we will explain this again. Now we are just doing the definitions. So this may seem new to you, but when we practice, it will make a lot more sense. So now that we talked about the confidence level, let's talk about how we put these together, and we construct not just an interval, a confidence interval. A confidence interval is a specific interval estimate of a parameter determined by using data obtained from the sample and by using a specific confidence level of the estimate. So we take data from the sample. We start with a sample point estimate associated with a probability. Going through a step-by-step process, we find the confidence interval for a parameter. So we are estimating parameter. We know how to find statistics. We're not doing a confidence interval for a statistic. Keep that in mind. We will be estimating parameter. To start this process, we will need to find the critical values. What are those critical values? Critical values are actually z-scores. The notation for a critical value can be this one, which seems weird to you at this point, or I have a better version, an easier version. I'll give you both options. So z and the subscript is alpha over 2, or z and c from critical. You will see both of these notations. I will use ZC a lot because for me it's easier. But this means that the critical value, Z alpha over 2 or ZC, is the Z-score such that the area to the right of it, it's exactly alpha over 2, which means the area between the two critical values, it's exactly C. And C is the confidence level. You see, this is given as a percentage or a probability. To better understand all of this idea, let's visualize it. So this is what happens, and this will actually be the first step in creating a confidence interval, finding the critical values. And we'll be working with different distributions. I'll just give you the example based on the Z critical values, which means we are working with a standard normal distribution. And this is the area in between. Area is probability. We will say that this is the C or the confidence level, C%, the confidence level, the probability associated with the confidence interval. Now, C plus alpha, and this is where the new notation comes in, the confidence level plus alpha is the entire area under the curve. So if we want to find the area in these tails, we are actually subtracting C from 100% and split the area in two. So what we actually have in this tail, it's an area of half over 2. This is an alpha over 2. So the critical value is actually the positive of these two. The notation is z alpha over 2. Here is why we have the notation z alpha over 2. This will be negative. The definition says the critical value is the z-score such that the area to the right, it's exactly alpha over 2. They mean you will always have two critical values, but in the formulas that we will be using, we will be looking at the positive one of the two. Now, how do we find critical values? Because as I said, this is the first step in creating a confidence intervals. In order to answer this question, we have to think of how did we find the z-score? Well, the answer to that was we used inverse norm. It's not the first time we find a z-score. We just call this z-score now a critical value. And we have to put in area to the left, 0 and 1, because we are working with this standard normal distribution. So this is the first step in estimating a parameter, finding critical value. Let's do that for a confidence level of 90%. When you have to find critical values, you will start the process by sketching the graph. Remember, these are z values, so you will be using the standard normal distribution. Sketch the graph. This is a z distribution. We have a 0 right here. And remember, the C or CL is the percent associated with the confidence level, which is right here inside. We're not really focusing too much on this because to find the critical values, we will actually have to find the area in the tails. Now, if we have 90% in the middle, we have 10% split in two, which is 0.05 in each tail. So the critical values will be negative ZC, ZC. And to find this, actually, I think it will be a lot easier to use this area, right, in the formula. And I will find a negative critical value. And I use the notation ZC instead of alpha over 2, just because it's easier to write it down, okay? And this will be inverse norm of 0.05, 0, 1. And if you use the calculator, you will find the value of negative 1.645. We usually round this up to 2 decimal places since this is a z value. However, in this case, this value is right between two values. So this is the one that we will actually keep as 3 decimal places. So I will say ZC is 1.645, which is the same as this notation. So again, the critical value, we have 2 critical values in the formula, so we will be using the positive ones. And you may also see this notation, or if you want to say, okay, I have 2 critical values, just put a plus and a minus to each one of these. In the upcoming formulas, we'll be using the positive ones, but for now, yes, there are 2, 1 negative and 1 positive. So this is the first step, know how to find the critical values. And hopefully you do recall this process, know how to find values given probabilities. And actually these values are in the table. So at some point after you will practice with this, you will actually remember the values. Here is a table for the confidence interval of 90%. We already found the critical value as 1.645, and I'm referring to the positive one. And then we have the most commonly used confidence level and the critical values associated with this. It says right here, verify each of the following using the inverse norm function. Let's just verify one more and I will let you verify the other ones. Let's just look at this one. If the confidence level is 98%, find the critical value ZC. And we'll be looking again at the positive one, sketch the graph. This is the Z distribution. And this is 0, and we know right here in the middle, we have 0.98. So focus on what's left in these 2 tails, and then you'll be able to figure out the negative ZC and the positive ZC critical values. So what's left in those cells is 1 minus 0.98, which is 0.02. And then the 0.02 should be split in 2, so it will be 0.01. This is the area, and you will simply find first the negative ZC. That's just because it's easier. Inverse norm, so take the calculator, plug in the 0.01 and then 0.1, and check that your answer is about 2.33. Actually, it's negative. That's a negative, which means ZC, it's indeed 2.33. So make sure you check the other ones and make sure you know how to find these critical values, because this is the most important step in creating a confidence interval. If we understand this, then we will go ahead and create confidence intervals by plugging these numbers in some formulas. So this is what we will do. General idea. When we have to construct a confidence interval, we start with a point estimate and we add and subtract something that is called a margin of error. By subtracting the margin of error, we will get to a lower bound. By adding the margin of error, we will get to the upper bound. Now, how do we find the margin of error? We have specific formulas for specific situations, and that's what we will do in the next video. With this, we conclude this introductory video for confidence intervals.